Summative Assessment Chapter 5, Solving Exponential and Logarithmic Problems by Kimberly Tai. So it's 5 to the power of x minus 3 equals 25 to the power of x minus 5. So what we want to do is change 25 to have the same base as 5. And so we know that 25 equals 5 to the power of 2. So we're going to be changing 25 for 5 to the power of 2. So 5 to the power of x minus 3 equals 5 to the power of 2 times x minus 5. And so from here, since they have the same base, we can just cross it out and bring down the exponents. And so it's going to be x minus 3 equals 2 times x minus 5. And so we're going to be distributing the 2. And so we're going to get x minus 3 equals 2x minus 10. And so from here, we're going to solve for x. And so I'm going to subtract x from both sides and then add 10 to both sides. And I should get 7. And so to make sure that 7 does equal x, I'm going to plug it back into the equation. And so we're going to do the same thing, and I'm going to change the base here. So 5 to the power of x minus 3 equals 5 to the power of 2 times x minus 5. So that's going to be 5 to the power of 4 equals 5 to the power of 2 times 2, which equals 5 to the power of 4 equals 5 to the power of 4. And so this means that x does equal 7. 184, which is log 4 x plus 12 plus log 4 x equals 3. And so what we want to do is condense this problem. So we're going to make sure, and since they have the same base, we're going to be doing log 4 and then combine these two. And so it's going to be x plus 12 times x equals 3. And this is because the product property of logarithms. And so yeah, it's going to be like that. And then from here, we're going to try and get rid of the log. So I'm going to do 4. And so that gets rid of the log here. And so I'm going to bring this down. So it's going to be x plus 12 times x equals 4 to the power of 3. And so from here, I'm going to distribute the x. So it's going to be x squared plus 12x equals 64, since 4/3 equals 64. And then I'm going to subtract 64 from both sides so it equals 0, so we can factor to solve for x. And so I'm going to be doing cross simplifying. So 1 times negative 64 equals negative 64. And so I'm going to write b here. And so 16 times negative 4 equals negative 64. And 16 minus 4 equals 12. And since a equals 1, I don't have to make a box. So I can just do x plus 16 times x minus 4 equals 0. And so if I solve this, it's going to be x equals negative 16 and x equals 4. And so I'm going to be checking for an extraneous answer. And so I'm going to be plugging negative 16 and 4 back into the equation. So let me do that. And so from here, I'm going to be solving it. So log 4, and so negative 16 plus 12 equals negative 4 plus log 4 negative 16 equals 3. And so I can't solve this anymore, and so this is false. So we know that this is an extraneous answer. And so I'm going to be checking 4 now. So log 4 plus 12 plus log 4 times 4 equals 3. And so I'm going to be doing log 4, 16 plus log 4 equals 3. And then by the product property of logarithms, I'm going to be combining 16 and 4, since they have the same base, which is log 4. And so 16 times 4 is 64 equals 3. And then I'm going to be changing this up by keeping the base here and then switching 64 and 3. So it's going to be 4 to the power of 3 equals 64. And so 4 to the power of 3 does equal 64. So we know that x equals 4 is our answer. And so it says that Aiden invested $600 in a savings account with 5% interest rate that compounds monthly. And so what would the value of Aiden's account be after 8 years? And how long will it take for him to triple his investment? So the equation that we want to start out with is A equals P times 1 plus R over N to the power of N times T. And so we're going to be solving for A. And so P is the initial amount that Aiden put in, so which is $600. And so we're going to times that by 1 plus, and then R is the rate, which is 5%, and 5% equals 0.05 as a decimal. So that's going to be this. And it's going to be over 12 because it compounds monthly, and so there are 12 months in a year. And so we're going to multiply that by 8 since it's asking for what the value will be after 8 years. And so we have our equation right here, so we're going to solve that. So it's going to be 600 times 1.004166667 times 96. And then we're going to multiply, we're going to do this number to the power of 96, which is 600 times 1.4905855515. And then we're going to multiply these two, which should be 894 plus 0.3513093. And so this is going to be how much will be in Aiden's account after 8 years, which is going to be $894.35. And then the second question is asking how long will it take for him to triple his investment. And so by tripling, we want to find out how long it will take for $18,000 to be in his account, since 600 times 3 is 1,800. So we're going to be using the same problem as before, but substituting A for 1,800 and solving for T. So it's going to be 1,800 equals 600 times 1 plus 0.05 over 12 to the power of 12T. And so from here, we're going to be solving this right here. So it's going to be 1,800 equals 600 times 1.004166667 to the power of 12T. And then we're going to be dividing both sides by 600 to get rid of this. And so that's going to be 3. And so it's going to be 3 equals 1.004166667 to the power of 12T. But we want to make sure that this 12T is a normal number, so we want to bring it down. And by doing that, we're going to do log to both sides. And so that's going to be log 3 equals 12T log 1.004166667. And then we're going to divide both sides by 12 log 1.004166667 to get rid to make sure that everything equals T. And so after doing this, we're going to be plugging it into our calculator. And so log 3 is 0.477121255. And then 12 log 1.004166667 is 0.0216696112. And so after doing this, T should equals 22.01798,791, which if we round is going to equal 22 years. So this means that after 8 years, there will be $894.35 in Aiden's account, and after 22 years, Aiden's investment will triple.